What would you say if I told you that I can replace 5 antennas supporting 5 different missions with a single antenna? What about replacing 10 antennas or 20 antennas with one single antenna? Or how about the ability to simultaneously receive signals across the entire sky? Would this be something that interests you? Hopefully your answer is yes. Please tell me more. So let's get started. Hello, and thank you for joining us today. My name is Ken Kwok, and I am the Senior Director of Strategy and Technology at ATG, which stands for APOTHYM Technologies Group. And I want to talk to you about our innovative antenna technology whose applications are only limited by your imagination. One application we're going to talk about today is for multi-LEO satellite constellations in a low size, weight, power, and cost form factor, or SWaP-C. So who are we? ATG is a technology innovator in the communications space. We focus on research and development in wired and wireless communications technology, specifically digitization and virtualization technologies and advanced antenna technologies. We have 2 office locations. The first is our corporate headquarters in Peachtree Corners, Georgia, which is a suburb outside of Atlanta, which is where we do all of our advanced antenna development. And our second office is located in the DC metro area in Frederick, Maryland, where we do all of our waveform virtualization and digital IF development. We have several ongoing Phase 1 and Phase 2 SBIR development efforts to include next-generation antenna development, which is what we're going to talk about today, and SBIRs for waveform virtualization, all digital modem development, and alternative position navigation and timing, or alt-PNT solutions. We are also doing antenna and radio development for hypersonics and have a TRL 6/7 antenna product that has been flown on the H4H campaign. In 2017, ATG was awarded a Phase 1 SBIR by U.S. Army SURDEC to develop a low-cost antenna to support Blue Force tracking over the wideband global SATCOM constellation, or WGS. Since that initial award, new requirements emerged, such as the requirement to support next-generation low Earth orbiting satellite constellations, or LEOs, support for multiple satellite bands, and multiple satellites simultaneously. This led to a Phase 2 SBIR award by U.S. Navy PMW 170 in 2020 to develop a low SWaP-C multi-LEO satellite antenna. Now, we did not want to just take current antenna technology and add LEO support to it. We wanted to take it a step further and develop a disruptive antenna technology where supporting traditional SATCOM and next-generation LEO satellite support is only a small subset of the applications of this antenna. And we're going to talk about that in the following slides. To develop this technology, ATG formed an advanced antenna research team specializing in advanced antenna design and a technology innovation team with a wealth of industry experience developing commercial and military satellite communication systems. So what does all this mean, and what are we trying to solve here? Next-generation LEO satellite constellations have been making a big splash across the satellite industry. Companies like Starlink, Amazon Kuiper, OneWeb, and Telesat are all launching thousands of satellites to provide low-cost, high-speed internet to everywhere on the globe. Being able to access all of these different networks simultaneously with a single antenna require a new generation of tracking antennas capable of tracking multiple satellites simultaneously. Traditional parabolic or dish antennas require mechanical steering to track moving targets, but it can only track one satellite at a time. Phased array antennas are electronically steered, but can't see down to the horizon, are limited in bandwidth, require high power, and have degraded performance when generating more than one beam. ATG's antenna is based on a Lundberg lens, which combines some of the best features of a mechanically steered and an electronically steered antenna, while also enabling new capabilities for resilient communications. Our antenna is solid state, so no moving parts. It can support multiple simultaneous beams pointing to different satellites in the sky, with no performance degradation. We have wide sky coverage down to near horizon and low power consumption. We are also network agnostic and can integrate with any modem. Now, development of this amazing technology does not come without its own challenges. It requires advanced materials and manufacturing for the lens, advanced state-of-the-art RF electronics, and advanced modeling and simulation techniques to optimize the design. So where can you use this? Our antenna can be scaled in size to support mobile platforms such as ships, submarines, land mobile vehicles, and manned and unmanned airborne platforms. Our target is to be able to replace almost any currently fielded mechanically steered parabolic antenna on any platform. Because the Lumberg lens can also support a very wide frequency range, it can be designed to operate at almost any frequency band such as L, X, Ku, Ka, and mil-Ka. As mentioned in the previous slide, we are network agnostic and can integrate with any modem to provide network flexibility and multi-mission support. As part of our current development effort, we are integrating with the OneWeb modem and are targeting being able to support up to 4 simultaneous transmit beams. Now, the number of simultaneous transmit beams can be scaled up depending on user requirements. All 4 services, as well as the intelligence community, have identified a need for a resilient multi-beam, multi-mission antenna solution that can support next-generation LEO satellites. So we talked about the what and the where. Now let's talk about the how and the why. The Lumberg lens concept has been around since the 1940s and has been used in military applications such as radar and microwave antennas. Up until now, the implementation of a Lumberg lens for SATCOM applications has been limited by technology and a lack of imagination. However, with today's advanced RF electronics and modern lens materials, coupled with ATG's design approach, we have developed a Lumberg lens-based satellite antenna that is realized using 2 key innovations. The first key innovation is an extensive feed network of over 2,000 feeds, where each feed generates a single beam through a focal point on the Lumberg lens. When you overlay all 2,000 plus beams together, they form a honeycomb of overlapping beams across the lens shown in the diagram on the lower right. To point to a particular satellite, you would just turn on the respective beam that looks at that sky position. And then, as the satellite or platform moves, you would just do a beam handover to the next adjacent beam on the lens. If you wanted to point or track more than one satellite, you would just turn on one or more of the 2,000 plus available beams. The second key innovation is a complex switching matrix that connects multiple beams to multiple modems, radios, and/or sensors simultaneously. So in addition to being modem agnostic, we can support multiple modems or missions simultaneously through the switch matrix. So remember when I mentioned in the beginning of this presentation about replacing 5 or 10 or even 20 antennas with a single antenna, this is how we do that. Each beam acts as an independent antenna, and the number of simultaneous transit receive beams you can enable equates to the number of antennas you can replace with our one antenna. From a receive-only perspective, you can actually enable all of the beams simultaneously to have a full sky sensor array. All of these things are possible with the right configuration. If you look across the market at comparable antennas, ATG's antenna does everything a traditional parabolic antenna does, plus delivers capabilities beyond some of the newer, more advanced electronically steered array antennas on the market. ATG's multi-beam technology is a key differentiator and enables simultaneous, multi-network, multi-mission, and multi-application support. And from a cost perspective, the multi-beam capability can mean a much lower cost per beam compared to other antenna technologies, which can only do 1 beam per antenna, or maybe 2 beams, but at a degraded performance level. Our current Phase 2 SBIR has concluded with the development of a TRL-4 antenna prototype and a demonstration of initial capability. Follow-on development efforts under the Army G2 ISR Task Force Rapid Defense Experimentation Reserve Program, or RAIDER, will advance the antenna from TRL-4 to TRL-6 in CY 2023. The development will culminate with participation in the Valiant Shield exercise in 2024, which will include 3 terminals on 3 different platforms, including ships and submarines. We currently have 2 paths we are working on to move the terminal beyond Phase 2. We continue to engage Navy PMW 170 to identify capability gaps across the Navy and are tracking on the growing need for connectivity to LEO satellites. In addition, we are looking for opportunities on current platforms that have end-of-life antenna systems requiring a technology refresh and new expanded capabilities such as interference mitigation and multi-LEO network access. By participating in the Valiant Shield exercise under the Army Raider program, we have a path to maturing the product from TRL-4 to TRL-6 and an opportunity to prove this technology in an operational environment. At the end of the Raider program, we will be in a strong position to productize the antenna for land mobile, maritime, and aero platforms. As you know, there are LEO constellations such as OneWeb and Starlink already deployed, with more satellites being launched each week and more networks such as Amazon Kuiper on the way. So there's an immediate need across all of the services to provide terminals that can support LEO and legacy SATCOM networks, as well as meet DoD requirements for low power consumption, mil-standard environmentals, and interference mitigation. ATG's antenna supports all of these capabilities, plus adds multi-beam support. In addition to the 2 transition paths already mentioned, ATG is actively looking for additional programs to transition this technology to, as well as commercial and DoD partners to help fund additional capabilities and technology enhancements to support specific customer use cases and other emerging satellite networks. Examples of this are smaller or larger form factors for specific mission needs or platforms, ISR and sensor applications, aviation platforms, alternative position, navigation, and timing solutions, and electronic warfare, just to name a few. For the latest information on our technology and products, please reach out to the points of contact shown here, or you can visit our website at atg.space. Thank you everyone for tuning in to our presentation today, and we hope to be hearing from you soon.